Welcome once again to the lecture on the renal system. Today we'll be dealing with the structure of the renal tubule. The renal tubule. So let's look at it. So this is a typical structure. Forget about the electrolytes that are on it. This is basically the structure of the renal tubule. So let's look at it in details. What are the components? So this is made up of the proximal convoluted tubule, made up of the loop of Henle, which we have the descending loop, ascending loop, and with the ascending, as you can see, we have thin and then we have thick part of the ascending loop. Then we have the distal convoluted tubule, then we have the collecting duct. So basically, this is just the structure of it. But let's move to each and every part of the renal tubule. So let's deal with the proximal convoluted tubule, which is the initial part of the renal tubule. So it is divided into two parts. We have the initial part, and then we have the descending or the straight part or the straight portion. Now it is basically found in the cortex. Then over here, as you can see, this is found in the medulla. We have the luminal side or the luminal part. Then we have the basolateral side. Basolateral side. Now the luminal side, that is the side that is facing the lumen, is made up of brush borders. This increase the surface area for absorption. When we begin to deal with the functionalities or the functions of this part or the mechanisms involved in regulation of the filtrate, you shall see what the brush borders are really doing. Then on the basolateral side, which is the side that is away from the lumen, it is made up of mitochondria, because that part has a lot of activities going on there. Yes, a lot of activities going on there, actively going on there. And that means it requires a lot of what? ATP. That is what? Energy for its functions. Then in between the cells, we have what we call tight junctions. So it connects neighboring cells together. So briefly, that is what it is all about when it comes to the proximal convoluted tubule. Of course, this part is very permeable to water. Usually about 65% of the filtrate or the water that is filtered is reabsorbed in this part. Alright, so let's move to the other part, which is the loop of Henle. So it is usually a U-shaped, as you can see, which begins from the proximal convoluted tubule. Now it consists, as we said earlier on, the descending limb and the ascending limb. The ascending limb is further divided into thin and thick. Now take note of this part because sometimes or usually in MCQ they ask it a lot. So the descending limb is permeable to water, but less permeable to salt. What it means is that filtrate over here is very what? Concentrated. Very concentrated because water is moving out and the salt is not moving out. The ascending limb to the early distal tubule is very impermeable to water. That means water is not allowed to move out of the tubule, thereby making dilution possible. Or there is a part whereby the filtrate is very what? Diluted. However, as I said, the other part is very impermeable to salt, but over here is very permeable to salt, actively permeable to salt. So please take note of that. And that makes diluting very, very what? Possible. Now, the next part is the distal convoluted tubule. As you can see, we have the early part, then we have the what? The late part. Now, the early part, as said earlier on, is very impermeable to water. Now, the luminal areas or the luminal side have receptors for parathyroid hormones, while the basolateral side have what we call calcium ATPases. Calcium ATPases. When we begin the functionalities or the functions or the regulations of electrolyte, you shall see how this part is working. So please bear with me as we move on. Now the late part fuses with the collecting duct, and this part is made up of two cells, intercalated and principal cells. Once again, when we start with the functionalities, we shall know how each and every one, the roles they are playing. Now, permeability of water here depends on ADH, anti-diuretic hormone. So if anti-diuretic hormone is being released, anti means against water or against diuresis. So that means that it prevents water from being excreted, or it reduces urine. Exactly. Now, if ADH is not produced, what it means is that water can easily flow out of the tubule, isn't it? Exactly. So, as I said, we shall enter more about it in future lectures. Alright. Now, the last part of the tubule, we have the collecting duct or the collecting tubule. This is your collecting tubule. Now, it is the final part of the nephron which drains into the renal calyces and finally into the renal pelvis, then the ureter, then the bladder, then the urethra, then outside. Exactly. Alright. Now, it has both the intercalated and the principal cells, just like the late distal convoluted tubule. Then it is also divided, as you can see, it begins from the cortex into the what? The medullary. So we have the cortical collecting tubule, then we have the inner medullary collecting tubule. Once again, permeability of water depends on LDH. And again, the medullary segment has special transporters for urea. So you see here, urea is filtered out, or let me say is reabsorbed, then it comes back to the loop of Henle to be taken up again, or to be secreted into the loop of Henle. So basically, that is just the structure of the renal tubule. And in our next lecture, we will be dealing with JFR. I'm sure you might have heard it. That's the glomerular filtration rate. You don't want to miss this. So please stay tuned and make sure you follow us on our media platform, YouTube, and make sure you subscribe if you have not subscribed to it. And please do well to share and let us know what you think about what we have just informed you or given to you. Alright, so I hope you enjoyed it. So do have a wonderful studies. Bye.